Hello friends. So welcome you all to the next session on continuity and differentiability. That is, in that we are going to discuss differentiation in particular. Okay. Today we are going to discuss one of the easy and important concepts of differentiation, among which the first one is parametric differentiation. Okay. First we are going to see what is the concept of parametric differentiation, and then we shall take examples to clear the topic. Okay, so let's directly get on to the topic. Now friends, in parametric differentiation we will be having two variables. We know generally we know a function y is equal to f of x type. Okay, but here we are going to see both the functions y and x in terms of another parameter, either t or theta. For example, I may have a function like x is equal to f of t. X will be a function of t and y will again be a y will also be another function of t. In this case, I want to find out dy by dx. How do you find dy by dx? It's very easy. Remember, first what you do it is dy by dx is nothing but you differentiate y function with respect to the parameter t and then differentiate the x function with respect to the parameter t. So dy by dx will be dy by dt divided by dx by dt, or remember, or sometimes you will be having x as a function of theta and also y will be another function, let me say g of theta. Okay, then first I'll find out dx by dt, d theta I will find it out. Similarly, I'll find out dy by d theta. Generally we have in your second PUC you will either have the parameter t or you will have the parameter theta. Okay, therefore if you have to find out dy by dx, I think you are guessing it right. If it is t, then it is dy by dt, and if it is theta, then it is dy by d theta divided by dx by d theta. You have to remember this formula, very simple formula. Is it clear? Either you have dy by dx is dy by dt by dx by dt, or you will be having dy by d theta divided by dx by d theta. Now you might be wondering how you have problems on this case. Now we'll directly take one first example and you will be knowing how to solve it. Now let us consider one basic example. This is a worked example in your textbook. Find dy by dx in the following cases. Now I am given with x is equal to at square and y is equal to 2at. Okay, as I told you, the parameter here is t. Okay, so first you differentiate both the functions in terms of the parameter. Okay, now we know a is a constant, keep it as it is. Now derivative of t square. Now remember, in place of x you will be having t, so you are differentiating with respect to t. Okay, so derivative of x square. What is derivative of x square? 2x. So derivative of t square will be 2t. That's all. So I have dx by dt is nothing but 2at. Okay, similarly let me go for dy by dt. In terms of dy by dt, 2a is a constant, keep it outside. Now derivative of t. What is derivative of x? Derivative of x in terms of x is 1. Similarly derivative of t in terms of t is 1. So this is nothing but 2a into 1 is 2a. Remember, for parametric differentiation, most of the time they will be giving for 3 mark questions. So to write dx by dt you will get a 1 mark. To write dy by dt you will get 1 mark. Therefore, remember, dy by dx is nothing but dy by dt divided by dx by dt. Okay, remember this formula. This is an easy one. So what is dy by dt? You already have here. It is nothing but 2a divided by What is dx by dt? You have already found it out. So it is 2a divided by t. So this is nothing but 2 gets cancels, a gets cancels. So nothing is in the numerator. Don't say 0. I have 1 in the numerator and t in the denominator. Therefore, you can write dy by dx. Okay. Therefore, dy by dx is nothing but 1 divided by t. Okay. Right. Once you get the answer, just frame it up. Okay. Very simple, isn't it? So what you do it is, check the parameter, differentiate x in terms of that parameter, first case. Differentiate y in terms of that parameter, second thing. Finally, take the formula dy by dx in terms of that parameter, divide it, and whatever is remaining will be your dy by dx. Okay? Right. We'll move on to the next question. We are moving on to the next question, friends. Now we can see here I am given with x is equal to a cos theta and y is equal to a sin theta. In this case, the parameter both are expressed in terms of theta. So remember, first we find out dx by d theta. Okay. In this case, now a is a constant, keep it as it is. Now derivative of cos theta. What is derivative of cos? I think you should be remembering all these things from the first class. So derivative of cos is minus sine. Therefore, if you multiply, I'll get minus a sine theta. Okay. So 1 mark you will be getting it to get dx by d theta. Now I'm going to find out dy by d theta. Here y is a sine theta. A is a constant. Keep it outside. What is derivative of sine? Derivative of sine is nothing but cos plus cos, isn't it? So I get a cos theta. Okay. So I got dx by d theta and I got dy by d theta. So I'm going to substitute into the formula. Therefore, dy by dx is nothing but dy by d theta divided by dx by d theta. Okay. So that is nothing but what is dy by d theta? I have here, it is a cos theta divided by, I have minus a sin theta because dx by theta is minus a sin theta. This is nothing but, now a and a will be cancelled. I will be having minus. I have minus cos theta by sin theta. Okay. So this is nothing but, I can finally write dy by dx is nothing but, minus is kept outside. What is cos by sin? We all know cos by sin is nothing but cot theta. So this will complete my solution. Okay. So this is how I find the parametric forms of differentiation problems. Right. Okay. Now we shall move on to the next question. I have x is equal to 2at square and y is equal to a t power 4. This question was asked in March 2020 for 3 marks. Okay. So the parameter here is t. So what I'm going to do, I'm going to get dx by dt first. Remember, 2a is a constant. Now what is derivative of t square? So derivative of t square is like derivative of x square. So we know derivative of x square is 2x. Therefore derivative of t square is 2t. Okay. So this is nothing but, what is 2 into 2? I'll get 4a into t. Okay. So keep it as it is. If you want, you can consider this as equation 1. Okay. Now let me find out dy by dt. So this is nothing but, again a is a constant. I have to differentiate t power 4. So derivative for t power 4 is 4 into t cube, isn't it? So this is nothing but, multiply it. I'll get 4a t cube. You can take it as equation 2. So you will be thorough with 2 marks. Okay. Finally, therefore dy by dx is nothing but, as I told you, don't forget to write this formula, dy by dt divided by dx by dt. Okay. So this is nothing but, what is dy by dt? From equation 2 I have 4a t cube. Okay. Divided by, I have dx by dt is 4a t. Okay. Now you can see here 4 is common, 8 is common, and 1 t will be cancelled. So I'm just left over with t square. Okay, or else you can write it one more time. Therefore, dy by dx is nothing but t square. This is a very easy question which was asked in the March 2020 year for 3 marks. So you can easily get 3 marks in parametric differentiation. Either 2 or 3 marks will be asked from this part. I hope you would be comfortable in solving this kind of questions. Okay friends? Okay, we'll move on to the next question. Now look at this question friends. I have x is equal to a cos theta and y is equal to b sin theta. B cos theta. Don't worry about what the function is. Just look at the parameter. Here the parameter is theta. Therefore dx by d theta is nothing but a is a constant. What is derivative of cos? We know derivative of cos is minus sine, and in terms of theta it is theta. Okay, similar you can express this. So it is minus a sine theta. Okay, similarly dy by d theta is nothing but, here b is constant, derivative of cos is again minus sine, parameter is theta. This is nothing but minus of b sine theta. Okay, so remember, therefore you can directly go on to dy by dx. So we all know that dy by dx is dy by d theta. Remember the parameter is theta here, divided by dx by d theta. Okay, so this is nothing but, what is dy by d theta? I already have here minus b sine theta. Okay, divided by minus a sine theta. Okay, so this is nothing but, I can cancel the minus term, I can cancel the sine term. I am just left over with b divided by a. This is the value of dy by dx for this question. Okay, very easy, isn't it? Right. So the next question what you have is, I have x is equal to sine t and y is equal to cos 2t. So this question was asked in March 2018. So remember, here the parameter is t. So I'm going to differentiate both x and y in terms of t. Okay, so dx by dt is nothing but, what is derivative of sine? We know derivative of sine is cos t. Okay, so you can just keep it as equation 1. Nothing, you can do nothing with this. Now next, dy by dt is nothing but, remember this is cos at. What is derivative of cos? Minus a into, that is a is 2. So minus a into sine at. A is 2. So sine 2t. Okay, now you can also split this sine 2t as, we know sine 2 theta is 2 sine t into cos t, isn't it? Sine 2t is 2 sine t into cos t. So minus will be kept as it is. 2 into 2 will be 4. So I have sine t into cos t. You can keep it as equation 2. Okay, therefore dy by dx is nothing but dy by dt divided by dx by dt. This is nothing but, now what is dy by dt? I have here minus 4 sine t into cos t divided by, I just have cos t. Okay, so it's very easy here. I can cancel cos. So the remaining term is minus 4 sine t. Okay, so this is my dy by dx. Okay, so you can easily get 3 marks if these kind of questions are given. Moving on to the next one. I have x is equal to 4t, a very simple question. Y is equal to 4 by t. Okay, the parameter here is, yes Subhash, what is the parameter? T. Good. So dx by dt is nothing but, so 4 is a constant. We know derivative of t is 1. So it is nothing but just 4. You can take it as equation 1. Now similarly, dy by dt is nothing but, again 4 is a constant. Remember, this is of the form 4 into 1 by t. What is derivative of 1 by t? I think you remember the formula which I told you to keep it. Derivative of 1 by t is minus 1 by t square. Okay. So I found out the derivative of 1 by t, which is minus 1 by t square. Only if you are familiar with your basic formulas, you can solve this kind of questions. So it is nothing but minus 4 divided by t square. So you can check this equation as 2. Okay. So finally I have to find out, therefore dy by dx is nothing but, I think you guessed it right, dy by dt divided by dx by dt. So this is nothing but, what is dy by dt? I have minus 4 divided by t square whole divided by, what is dx by dt? It is just 4. Okay. Now you can cancel this 4 and 4 because this comes here. Okay. So if you cancel, you are left over with minus 1 divided by t square. Therefore you can just write up here dy by dx is nothing but minus 1 by t square. Okay. So this is how you do it. And friends, bear it in mind, I am just using 2 different colors just for you to understand. You are not supposed to use 2 different colors in your examination. You will either be using black or blue. Okay. Use one single color, and you are never allowed to use red pens. Okay. Right. We shall move on to the next one. So I have x is equal to a secant theta and y is equal to b tan theta. Remember, the parameter here is theta. These questions are not asked even once in your examination. That means there are chances of these questions being asked this year. Okay. Okay, we'll move on. So consider dx by d theta is nothing but, a is a constant. Now what is derivative of secant? I hope you would remember the formula. Derivative of secant is secant into tan. So I have secant theta into tan theta. Okay, fine. So you can take it as equation 1. Now similarly, dy by d theta is nothing but, b is a constant, keep it outside. Now what is derivative of tan? We know derivative of tan is secant square and the parameter here is theta. So this is my dy by d theta. Okay. Therefore dy by dx is nothing but, we know it is dy by d theta divided by dx by d theta. Okay. So this is nothing but, take here, I have dy by d theta is, I have already found it out, b secant square theta. Okay. Divided by a into, I have secant theta into tan theta. Okay. So what I have is, your one secant term will be cancelled. So I am just left over with b by a into numerator is actually secant theta. What is actually secant? You can write it as secant theta divided by tan theta. Okay. You can keep it as it is just like this. Okay. Because unless they ask you to find, prove that, unless they say prove that question, you can leave here, or else you know that I'm going to solve here just for your benefit. So we know b by a, keep it as it is. We know derivative of secant is actually 1 by cos, isn't it? And tan is, you get sine by cos, isn't it? So secant is 1 by cos and tan is sine by cos. So if you can cancel, so you are left over with 1 by sine. So you can write b by a, 1 by sine is cosecant theta. This is the final answer. Remember, the left hand side is dy by dx. Okay. Or else it is enough for you to keep your, unless they ask you, show that dy by dx is equal to b by a cosecant theta. Okay. This is sufficient for you to get 3 marks. Okay. But always it's better for you to keep it in the more simplified way. Right? Good. We shall move on to the next question. So the next question what we have is y is equal to a into 1 minus cos theta, and x is equal to a into theta plus sin theta. Okay, so remember this question was asked 3 times in your examinations for 3 marks. Okay, so remember here the parameter is theta. So let me guess, dy by d theta is nothing but, your a is a constant, keep it outside. Now what is derivative of 1? 1 is a constant, so its derivative is 0, minus, what is derivative of cos? We know derivative of cos is minus sine. So minus of minus becomes plus sine theta. Okay, so I get dy by d theta is nothing but a sine theta. You can keep this as equation 1. Similarly, dx by d theta is equal to dx by d theta is equal to, again here a is a constant, keep it outside. What is derivative of theta? Derivative of theta is 1 plus derivative of what is sine? We know derivative of sine is nothing but cos theta. So I have a into 1 plus cos theta as it is. You need not write it once again, just keep it here. I got equation 2. Okay, so finally I'm going to use the formula to find dy by dx. Therefore dy by dx is nothing but dy by d theta divided by dx by d theta. Okay, so this is nothing but, what is dy by d theta? Please be careful what you are going to write. So a sin theta divided by a into 1 plus cos theta. Okay, now I will cancel a and a. Okay, so I am left over with sin theta divided by 1 plus cos theta. Now I am going to use the half angles formula to find the simplified form of this. Okay, so this is nothing but, remember in your half angles sin theta can be written as 2 sin theta by 2 into cos theta by 2. Similarly, check here, 1 plus cos theta can be written as 2 cos square theta by 2. Okay, so I'm going to use it here. So sin theta can be written as 2 sin theta by 2 into cos of theta by 2 divided by, I told you what is 1 plus cos theta? It is 2 cos square theta by 2. You should remember these formulas. Okay, so it is 2 cos square theta by 2. Remember, I can cancel 2 and 2 here, and one term of cos will be cancelled. So I am left over with sin of theta by 2 divided by cos of theta by 2. So finally you can write this as, what is sin by cos? Sin by cos is tan. So I get tan of theta by 2. Okay, don't make a mistake of writing tan theta whole divided by 2. No, it's an half angles formula, tan of theta by 2. Therefore you can write it in a simplified way. Therefore dy by dx is nothing but tan of theta by 2. Because this problem has a little bit of simplification, this has been asked in your examination more than twice. Okay, be ready. Even if they ask you this time, you should be able to solve this question. Okay, moving on. So the next question we have is similar to the previous question. I have x is equal to a into theta minus sin theta and y is equal to a into 1 plus cos theta. Remember, this question may be asked like, if y is equal to a into 1 minus cos theta and x is equal to a into theta plus sin theta, prove that dy by dx is equal to tan theta by 2. Sometimes he'll ask you to prove that tan theta by 2. Okay, so you should be careful. If they ask you to prove that, then you have to keep it in the simplified way itself. So here the parameter is theta. So dx by d theta is nothing but, a is a constant, keep it outside. Derivative of theta is 1 minus, what is derivative of cos? Sorry, derivative of sin is cos theta. Okay, keep it as equation 1. Okay, similarly dy by d theta is nothing but, again a is a constant, keep it outside because it's multiplied. Derivative of 1 is 0. Now derivative of cos, we know it is minus sine theta. So this is nothing but I can write minus a sine theta. So I will take it as equation 2 here. Okay. Therefore, using the formula, therefore dy by dx. So dy by dx is dy by d theta divided by dx by d theta. So this is nothing but what is dy by d theta? I have minus a sine theta. Okay, minus a sine theta divided by a into 1 minus cos theta. Okay, now a can be cancelled. I am left over with minus sine theta divided by 1 minus cos theta. Okay, remember this can be written as minus, I'll keep outside. Now sine theta, as I told you, as similar as in the same previous problem, sine theta I'm going to write in terms of half angles. So it is nothing but 2 sine theta by 2. So sine theta is 2 sine theta by 2 into cos of theta by 2. Okay, divided by what is 1 minus cos theta? These are all standard formulas you should be remembering. 1 minus cos theta is nothing but 2 times sine square theta by 2. Okay, writing it out, 2 times I'll get sine square theta by 2. Okay, now 2 can be cancelled. One term of sine will be cancelled. So I am left over with minus is kept outside. I have cos of theta by 2 divided by only one term of sine is cancelled. So I'll get sine theta by 2. So this is nothing but what is cos by sine? We know cos by sine is nothing but cot. So it is minus cot theta by 2. Remember, don't forget to write the LHS. dy by dx is minus cot theta by 2. Generally, he'll ask this question as prove that question. He'll give you the question and ask you to say dy by dx is equal to cot minus of cot theta by 2. Okay, fine. As we move on to the next question, I have x is equal to cos theta minus cos 2 theta and y is equal to sin theta minus sin 2 theta. Okay, so parameter here is theta. So dx by d theta is nothing but, now what is derivative of cos? We know derivative of cos is minus of sin theta. Okay, now minus of sin theta minus, okay, now what is again derivative of cos a theta? So we know derivative of cos is minus, because I have a here, a will be multiplied. So derivative of cos a theta is minus a sin a theta. Okay, so you can write it in a simplified way like this is nothing but minus of minus becomes plus. So I have 2 sin 2 theta minus sin theta. Okay, so this will be your equation 1. Okay, well, fine. Moving on to the next one, I will find dy by d theta here. This is nothing but, now what is derivative of sine? We know derivative of sine is nothing but cos theta minus, what is the derivative of sine at? It is a cos at, that is 2 cos 2 theta. So this is nothing but, keep it as it is. I'm going to write it as cos theta minus 2 cos 2 theta. So that is my second equation. Therefore dy by dx is nothing but dy by d theta divided by dx by d theta. So this is nothing but, just substitute. I have cos theta minus 2 cos 2 theta divided by, keep dx by d theta. Please be careful, sometimes there are chances of you writing the reversed order. Don't do that. So dx by d theta is 2 sin 2 theta minus sin theta. Okay, just keep it as it is. Further simplification is not required. Okay, that's it. This question, though it has not been asked, there are chances of this question being asked in this year. So friends, so we have almost come to the conclusion of this session. with this last question. So let us take the last question of the session. I have x is equal to a into cos theta plus theta into sin theta. This is a very important question. Please be careful. This is quite different from the other questions we have solved until now. And y is a into sin theta minus theta into cos theta. Okay. The parameter here is, yes, Shreyas, theta. Good. So dx by d theta is nothing but, now remember, a is a constant. Okay. Now what is derivative of cos? We know derivative of cos theta is minus sin theta. Okay. Plus, remember, here I have theta into sin theta. So this is a product rule. Okay. Because I have a product of two functions, I have to use excuse me rule or product rule. So what is product rule? Keep first function as it is and differentiate sin x. So derivative of sin x will be, sin theta will be cos theta, plus now keep sin theta as it is, derivative of theta. What is derivative of theta? It is nothing but 1. Okay. Remember, this is, we are using product rule here. So this is nothing but a into, remove the bracket, I have minus sin theta plus theta cos theta plus sin theta. You can simplify, plus sin theta and minus sin theta can be cancelled. So I'll get a theta cos theta. This is my dx by d theta. Okay. Please be careful. I've just got dx by d theta. This was asked in March 2014 for 3 marks. So this will give you 1 mark. Now we are going to find out dy by d theta. This is nothing but, again, a is a constant. Keep it outside. Now what is derivative of sin theta? We know derivative of sin theta is cos theta. Okay. Now because I have a negative sign, please be very careful when you have negative sign. Now theta as it is, derivative of cos is minus sin theta, isn't it? Okay. Now this minus is kept outside. Don't worry about this minus. Now theta into derivative of cos is minus sin theta, plus, remember, for product rule the in between sign is plus. Now keep cos theta as it is, derivative of theta is 1. Okay. This is one of the major step you should be careful in this problem. So a into, remove the bracket now, I have cos theta. Now remember, it is theta into minus sin theta. Minus of minus becomes, I'll get plus theta sin theta. Okay. Now plus of minus becomes minus cos theta. Okay. We know plus cos theta and minus cos theta can be cancelled. So if you multiply, you are left over with a theta sin theta. So this is nothing but your dy by d theta. Okay. So we have almost come to the conclusion part of this question. Therefore, dy by dx is nothing but dy by d theta divided by dx by d theta. So this is nothing but, what is dy by d theta? I have a theta into sin theta divided by, what is dx by d theta? So it is a theta into, I have cos theta. Okay. Now I can cancel a and I can cancel theta. Okay. So I am left over with sin theta by cos theta. Now what is sin theta by cos theta? We know this is the basic function. Sin theta by cos theta is tan theta. So the left hand side is dy by dx. So for the given parametric functions, the dy by dx will be tan theta. Okay. So friends, we have come to the conclusion of this topic. So please be careful. This is one of the major topic where you will almost be getting a guarantee question in your main examination. Okay. Hope you enjoyed this session. So my only advice is, as far as possible, keep practicing these problems. The more you practice, the more you will be thorough with this concept. Okay. There are more further higher order questions on parametric differentiation. We are going to deal it in the next session. Okay. Just so keep waiting and also keep learning. So meet you all in the next session. Until then, take care and as usual, bye.